All right, let's do more practice with inverse Laplace transforms. In particular, let's try to find a function whose Laplace transform is e of minus 2s over 4s squared plus 12s plus 25. And remember, the first thing we want to do, we want to focus on the function without exponential terms, because then we'll add the exponential term back in. So focus on 1 over 4s squared plus 12s plus 25. Now, it turns out the denominator, we cannot factor it out further, so we can't really use partial fractions here. Instead, let's complete the square. And here we have to be a little bit more careful because of the 4. So notice 4s squared. Maybe write this down. Complete the square. How cute. It is a square. So 4s squared plus 12s plus 25. Again, let's first factor out the 4. So 4, I think, s squared plus 3s plus 25 fourths. I know, scary fractions. Fourths. And then remember how to complete the square. Is s squared plus 3s. You do s plus half of that. So 4 times. So in this case, s plus half of 3. 3 halves squared. And you subtract 3 halves squared. So minus 9 quarters plus 25 fourths. And then, well, minus 9 plus 25, that's 16. So 4 times s plus 3 halves squared plus 16 fourths, which becomes 4. So 4 times s plus 3 halves squared plus 4. And then you want to take reciprocals, because we have 1 over this whole shebang. So here. So 1 over 4s squared plus 12s plus 25. Second, 1 over 4s squared plus 12s plus 25 now becomes, so 1 over 4th, so 1/4 times 1 over that whole thing. So s plus 3 halves squared plus, again, 1/4 because we're taking the reciprocal of 4, and then 1 over the other thing because, again, by reciprocals. And notice now it's a little bit easier to recognize this as a Laplace transform, because this thing above, this is a shifted version. Version by not 3/2 units, but minus 3/2 units. Because it's minus 3/2 of, let's see, of 1/4 and then 1 over s squared plus 4, which, if you want, it's 1/4 and then Laplace transform of half sine of 2t. Because sine of 2t gives you 2 over s squared plus 4. And so in the end, it is 1/8 or Laplace transform of 1/8 sine of 2t. And so because we're shifting by minus 3/2 units, we have to add the exponential term back. So hence 1/4 and then 1 over s plus 3/2 squared plus 4 becomes the Laplace transform of e of minus 3/2 t. And then 1/8 sine of 2t. And then we're almost done. So we did the whole thing without the exponential term. And now if you scroll back, all we need to do is add the exponential term. So step 3. So what did we have? We had e of minus 2s. And I think it's s squared plus 12s plus 20, or 4s squared plus 12s plus 25. That becomes e of minus 2s times the Laplace transform that we found, 1/8 e of minus 3/2 t sine of 2t. Because this whole thing was 1 over 4s squared plus 12s plus 25. And then remember the exponential term, all it does, it shifts and jumps. So in the end, this gives you Laplace of 1/8 e of minus 3/2 t minus 2 sine of 2 times t minus 2. So that becomes our answer. So our answer is from f of t is 1/8 e of minus 3/2 t minus 2, and then sine of 2 t minus 2. I know it was a little bit involved, but it's like an excellent practice with completing the square, with shifting, and with adding back the exponential terms.